You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone, and thanks for being here today. I'm Kirk Mona, and joining me are Rachel Gimza and Victoria Thompson. We're all naturalists who together have scoured the world for weird and wonderful wonders, just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Hey, everybody, welcome to the show. Good to see you guys, as always.
Good to see you too.
Good to be here.
Oh, glad to be back.
I have to slightly apologize in advance for my topic because I think you'll see why shortly, because it may have a certain effect on you and possibly everybody listening.
Because
is
that really unusual for this show?
No.
Well, it's not like a disgust effect, just to be clear.
I see. I think our audience knows what they're getting themselves into when they push the play button. Anything can happen.
I would hope so at this point, yeah.
Today, I'm going to talk about a behavior that is incredibly common in humans, and not only humans. This is a behavior that occurs in pretty much every vertebrate, and yet it is very mysterious, and we don't totally know for sure why it happens. It occurs spontaneously, and we've even observed human fetuses in the womb doing this behavior, but it can also be very socially influenced.
Is it yawning?
I have a guess.
And when one person does this, other people around them tend to do it also. It's yawning. Yes.
Yes!
Yep, yawning. That's what I thought.
I was like, it could be a couple different things, and then you said it could be socially influenced. I'm like, it's yawning, isn't it? Yeah, we're going to yawn a million times in this segment. Oh, goodness.
Yes, we are.
I'm yawning now.
See?
Okay. It's not boring, I promise.
We all know what a yawn is because we all do it, of course. But for those of you who really are aching for a scientific definition, I'm going to quote a helpful paper I found. Quote, characterized by a three-phase response, yawns are defined by an involuntary and powerful gaping of the jaw, a temporary period of peak muscular contraction with head tilting and eye closure, and a passive closure of the jaw. Among terrestrial vertebrates, the first two phases of this response often include a deep inhalation of air, while the third phase is accompanied by a shorter expiration. That pretty much covers it.
Yeah.
Scientists tend to categorize yawns in two different ways. There are spontaneous yawns, which can occur in the absence of any kind of external influence, like those that occur if an animal's by itself, or like if you're a fetus, for example. So these would be known as physiological yawns. The other kind is socially contagious yawning. We all know that if we see someone else yawning, or even hear them, or sometimes even think about yawning, it frequently makes us want to yawn as well, which Kirk is doing
I just
right
yawned.
now.
I just yawned. You made me do it.
Trying so hard not to yawn.
I've
already yawned like 6
I yawn
times.
every time we're recording. Something about sitting down to record a podcast makes me yawn.
I yawned so much when I was writing
why.
this episode. I think I got it mostly out of my system.
Oh, Rachel.
And this...
Sorry.
I'm not going to be able to keep going. You are yawning too much. This socially contagious phenomenon is observed not just in people, but in some other animals as well, whereas physiological yawns are seen in all types of vertebrates. So the contagious yawning is really not a big surprise, only seen in social animals.
Right.
It's not seen in human children until they're past early childhood, so like preschool age, typically. And it's also apparently less frequent in people with autism, although it seems that this might be partly due that people with autism don't pay as much attention to other people's faces rather than like lack of contagiousness per se.
Right.
Anyway, because this contagious yawning occurs only in very social animals, the physiological yawning must have come first, evolutionarily speaking.
Yeah.
Mm-hmm.
Yeah.
if that makes sense. So
okay, there's yawn number 3 for me.
Yep. What is the purpose of physiological yawning?
You warned us.
I did warn you. One explanation that I had heard, and probably a lot of you have heard as well, is that it's a way of increasing oxygen supply in the blood.
Sure.
However, this was actually pretty much disproved as long ago as 1987. Because they were able to control I don't know, I didn't look into the details of the experiment.
Did you say as long ago as 1987?
Yes.
Because I just...
Yes, I know, old. Kirk.
See, that's a sigh. That's not a yawn.
It's a sigh, not a yawn, yeah.
It is almost...
Don't say it.
Yeah. Almost 40 years ago.
Hey, Kirk. I wasn't born yet.
Yeah.
Yeah, we know, Rachel.
Yeah, we know. We know, Rachel.
I like to remind you all, just every once in a while. It's fun.
Okay.
Getting back to the topic, though, with this idea of increasing oxygen supply in the blood, some animals' yawning is not actually necessarily accompanied by breathing. For example, dolphins. I'd also heard something sometime about the contagiousness being due to a need to equalize air pressure in your ears, and then it changes the air pressure somehow in the air around you, and that makes other people need to equalize the air pressure. That just seems ridiculous on its face. It doesn't make any sense. Yeah.
So no, but you're talking about the social thing there. So you were talking before about
No, I'm talking about physiological.
Oh, you said I thought you said social. Okay.
Well, I guess that would also be for physiological, but yeah, kind of both.
Well, yeah, and I was with the whole thing about the physiological, the adding oxygen thing. That's the first thing I thought of when you talked about that. But then as you were talking, I was going, wait a minute. She said that babies yawn in the womb.
Right.
They're not breathing air. It's like amniotic fluid. That doesn't make any sense.
However, there is good evidence that yawning accompanies what is called a state change. For example, between sleeping and waking, and vice versa, as well as between attention and boredom. I think we can all kind of think of some examples in our own life.
Yeah.
Yep.
There's also some neurological evidence shows that yawning can cause changes in the brain that make the brain more alert, physiological arousal. But that doesn't account for the fact that people also tend to yawn when they're tired and right before they go to sleep. So scientists think that it may be kind of linked in also with circadian rhythms. So generally yawns
but why?
Can make you more vigilant, but not if it's at bedtime. But the why and the how is what you're still wondering.
Yeah.
So yawning may help regulate brain temperature.
What? Hold on.
Yeah.
What?
There's some yes. There's some evidence that yawning increases blood flow in the brain and therefore heat exchange with the sinuses.
Wow. Well, my brain is really cooling off it during this show, I'll tell you.
Yeah.
Mm-hmm.
In support of this idea is evidence that in several species that were tested, brain temperature is higher before a yawn and lower afterwards. And
cool.
One group did an experiment that manipulated the temperature of people's brains by warming or cooling their necks. And they yawned more when they were hot.
Huh.
Really?
Yeah. So it's kind of interesting. And stress can also induce yawning in many different types of animals, with increased yawns occurring either in anticipation of a stressful event, such as paratroopers preparing to jump, or after the stressful event is over, but not during the stressful event, because it can actually be, a liability. If you're thinking about having to run from a tiger or
that's not a
you don't want
good
to be yawning
time.
while you're doing that.
Yeah.
Because your eyes are shut, your mouth is open. I don't want to be yawning if a tiger's coming at me. Mm-mm.
I was thinking of a tiger as well. You're like, that was supposed to be me trying to yawn, and I don't know what that was.
Nice job.
So that's the evidence we have about physiological yawning. As far as the social or contagious yawning goes, so this can be tied in with the brain cooling theory, but there's some evidence that yawning can increase how vigilant other members of the group are. Like if one animal yawns, the others are like, oh, they must be getting sleepy. Like, I better pay attention more.
Yeah, I heard that.
And so then the contagious yawning could be like to coordinate group activity. There's some limited evidence of this based on an observational study of lions. And with another that ties in with the brain cooling function. Yeah, the whole group vigilance thing. The contagious yawning is not seen in, so it hasn't been studied in that many animals because it's not that important.
It's tricky.
Yeah. So there's evidence for it in chimpanzees, bonobos, and orangutans, but not in gorillas.
Okay.
Most other primates don't seem to do it. Primates are what's mostly been studied. Domestic dogs do yawn in response to human yawns, but not yawns from other dogs. And then there's evidence.
That's interesting.
That's wild.
It is kind of interesting. Maybe because dogs have just been bred over so many thousands of years to pay very close attention to human faces.
To humans. Yeah. Wow.
There's some evidence for a few other mammals, including lions, as I mentioned, pigs, and captive wolves, and some evidence for sheep, African elephants, and southern elephant seals. The only non-mammal for which we have any evidence of contagious yawns is captive budgerigars. Budgies, parakeets.
Budgies, yeah.
Yeah,
oh, okay.
They looked at it in ravens, but didn't find any.
Wow.
Yeah.
Huh.
Interesting.
So to sum up, yawning is a really complex behavior that we don't understand very well.
Great.
It is weird. It's it's really strange that we do it.
So bizarre.
I'd also heard a theory, I think, that with regard to primates, I think they're saying that if you yawn, you're showing your sharp teeth. And it's sort of hey, look, I may be drowsy, but I'm still a threat or something like that. I don't know.
Oh, thank you for bringing that up, Kirk. There's a mouth gape, which is not a yawn. That's kind of a threat display, but it's separate. It doesn't have the head tilting, eye closing, and breathing aspects.
Huh.
So it is an opening of the mouth, but it's not actually a yawn.
Interesting. Okay.
Yeah.
Fascinating. Well, more to learn.
Yes. My main source this week was a paper from May of 2022 in Animal Behavior called The Causes and Consequences of Yawning in Animal Groups by Andrew C. Gallup. Yeah.
I'm glad we could yawn together, Kirk.
Yep. I'm not saying that it wasn't a boring topic. That was fascinating. I did keep tally.
Very fascinating.
I yawned 8 times during your segment, just because you kept talking about yawning.
Mm-hmm.
Gosh.
Mm-hmm. All right, we're gonna take a break, get the rest of your yawns out, and when we come back, it'll be Kirk.
Hey everybody, Kirk here. I want to take a minute here to tell you about another podcast, because if you like our show, I think you might also like a show called Tiny Matters. It's a science-based podcast about the little things that can have a big impact on our society, past and present. Tiny Matters hosts and former scientists Sam Jones and Debaki Chakravarti tackle questions like, why is wildlife thriving near the Chernobyl disaster site? How was IVF invented? Why did the dodo bird really go extinct? And does life exist beyond Earth? Sam and Debaki break these complex topics down into understandable segments while packing in captivating stories and history and embracing the awe and messiness that is science. So you should join them. New episodes of Tiny Matters drop every Wednesday, wherever you listen to podcasts. Check them out. Okay, so this week I have a pretty amazing story, and it has to do with camouflage. And just this week, I was actually working with kindergartners, and sadly, I had to be inside with them due to thunderstorms. Now, I don't mind going outside with kids when it's raining, but lightning tends to be a big no-no. This storm system later actually spawned tornadoes, which are even worse. But the point is that it was not a good day to go outside. So I ended up showing the kids a live toad and talking about their many adaptations, including their camouflage. And I'd asked the kids to make observations of the toad. Didn't even tell them we were going to be talking about that. But the coloration and the pattern were pretty much the first things that these kids keyed in on and named when we were looking at it. And even these kindergartners, most of them had heard the word camouflage. It's like a pretty familiar concept to them. And it is a really important thing in the animal kingdom. It can literally mean life or death. In the case of the toad, the camouflage is, I guess, partially their bumps, but mostly colors and patterns. That's pretty common. We see some versions of what we call breakup camouflage on many animals, like tigers have stripes, birds, like a lot of them are sort of streaked with brown. And these, break up their pattern and make them hard to see. And I think we've at least...
I would like to say, on that front, you look at a tiger and how orange and everything it is and think, I could spot that. No, you can't. No, you cannot. No. I struggle seeing deer really hard in the woods.
Yeah.
Wild.
It's really amazing. There's all different kinds of camouflage and stuff too. Like I think we've, deer, for example, are just sort of one color, but not, they're lighter on the bottom as well. They actually have what we call counter shading. I think we've talked about that briefly on the show. It's where animals are dark on the back and light on the bottom. That can be really great camouflage. Maybe not so much for the deer, but like for fish, for example, when they, from below, they blend in with the sky and from above, they blend in with the bottom. These are all related strategies. Yeah, you see it in birds a lot too. Another really different type of camouflage though is mimicry. And you have things like hoverflies that mimic bees. You have non-venomous snakes like the milk snake that mimic the venomous coral snake. And one of my favorites, and we haven't talked about this on the show, but it's the giant swallowtail butterfly whose caterpillar mimics bird droppings.
Yeah.
So when they're sitting on a leaf, it just looks like a big old right on the leaf there. Just amazing.
So good.
They're afraid of being eaten by birds, so why not mimic bird droppings, something that a bird has zero interest in eating. Absolutely brilliant. Well, today I have a story for you about camouflage, but specifically it is also about mimicry, and it just so happens to involve a caterpillar. Now, when you picture a caterpillar, what food source do you usually picture them eating?
Leaves.
In general. Leaves. Yeah, leaves of plants, right? And if you were to ask me, like, what do caterpillars eat? I'd normally say, well, it's going to depend, but they pretty much munch on leaves. And that's usually where we find them. No big surprise there, is on leaves. That is usual, just caterpillar food.
Yeah, some of them, I guess, will eat, like, scat and things, I guess. But
there are some strange things that caterpillars will eat. Some caterpillars are actually carnivorous. There is such a thing as a predatory caterpillar.
Whoa,
they are rare. They make up less than 0.13% of the nearly 200,000 global moth and butterfly species. So that's a pretty astoundingly small percentage. But this poses a bit of a problem. When I think of a predator, like a caterpillar isn't really what comes to mind, right?
Oh, here comes the mighty, the fearsome,
the caterpillar.
It's a little bitty caterpillar.
I'll be there in a minute. Just wait, I'm coming. Hold on. I think some of them are actually ambush caterpillar.
Yeah.
Some of them are actually like ambush predators. As you can imagine, they're not fast. Caterpillars are slow. Eating leaves suits them well. And there's lots of leaves. But finding a prey species, that's a lot tougher. But one ingenious caterpillar, a species in Hawaii, was recently discovered to have a super cool solution to finding that food.
Kirk.
And I think Victoria saw this story. I know.
I have no idea about this.
This caterpillar, basically live in their version of a grocery store. And so think about, they eat insects. Well, where can you find lots of insects to eat? Why, in a spider's web, of course.
What?
Yeah.
Yeah. So, okay. Sure. Fair enough. A spider's web
But
is
isn't the
certainly
spider
a
gonna
place.
eat ya?
Yeah, that's problematic. We'll get to that. There generally are a lot of insects to eat there, but as you pointed out perfectly, Rachel, you're also going to find a spider. So it's kind of like saying that your angry and hostile neighbor always seems to have food on his grill. So your plan for how you're going to get all the food you need to feed yourself for the rest of your life is just to constantly steal food off his grill when he isn't looking. Is it possible? Maybe. Is it risky? Absolutely. With your angry, hostile neighbor, yeah, not a good idea. In the case of the caterpillar, getting caught stealing food from the spider's web could obviously have deadly consequences. The spider is not okay with this arrangement. So what to do then? Well, remember, I started this all off by talking about camouflage. So how do you hide yourself when you're literally living on the spider's web, stealing their food, or at least stealing some of the scraps of their food every day? Well, the answer is simple. You collect up discarded body parts from the spider's prey, and you glue them all over your body to disguise yourself as a bunch of dead food garbage.
What?
Yep.
It's a trash pile.
Yes.
It's a garbage bin.
Not just a trash pile. This is a dead body part pile, Rachel. This has earned this particular moth the disquieting name, the Bone Collector Moth, which is just an absolute amazing name. And yeah. And for the pedants, I'll chime in. Yes, there's no bones involved in this.
They're all insects.
Like the exoskeleton part collector moth. That doesn't sound as cool. Okay, they're the bone collector moth. The photos of this are really striking. Rachel's going to put them up on Instagram for you. You really can't see a caterpillar, though. They are completely encased in ant heads, random legs, beetle abdomens,
I love it.
And even shed pieces of the spider itself. And they'll just kind of grab some and kind of gnaw on them and make them just the right shape to fit them where they want and stick them on there. Researcher Daniel Rubinoff told Gizmodo in an interview that
this is
like hiding in Smaug's lair and stealing his treasure. And look, hats off to you, Daniel, for that incredibly nerdy Tolkien Hobbit reference. Though to be fair, he really should have extended the description more. Instead, it's like living in Smaug's cave, but hiding yourself by covering every inch of your body with the discarded bones and body parts of those who had previously been killed by Smaug.
Yeah.
Right? And if you have no idea what I'm talking about, you need to go read some Tolkien. All right. So anyways, back to the regular nerdy part of the show. I also want to point out that these bone collector moths are rare. If you're thinking, hey, I've never seen one of these. Yeah, they're very rare. In the 20 years that they've been studied, they've only been documented 62 times.
What?
So this is...
Dang.
Yeah, this is not something you're going to run across in your backyard. You may have caught that I said they were found in Hawaii. They are only found in a very small area on Oahu. Strangely, though, they may have once been more widespread. We talked on the show before about how scientists could get an idea of how long ago a species evolved by looking at their DNA. And one interesting piece of the puzzle here is that they did that for this species of caterpillar and found out that it is older than the island of Oahu.
What?
So we kind of get an idea of when it, broke off from other caterpillar species, and it did so before the island of Oahu existed. Now, if you know anything about the Hawaiian Islands, they are a series of islands that pop up over time as the Earth's crust shifts over a hot spot. So clearly these caterpillars, evolved on a different island long, millions of years ago and would fly to the next island and then fly to the next island and fly to the next island. But today, as far as we know, they're really only found just on Oahu. So sadly, the population is quite threatened due to all the ecological pressures on that island that it is currently facing. So it's being studied, but it's, the population is not doing well. So That's really what I wanted to share with you. Just the fact that there's something called the Bone Collector Moth whose caterpillar just glues dead body parts to itself for camouflage. That is absolutely
join.
astounding.
Didn't we talk about an ant who did this?
There was something else that did something similar. I think we talked about once on the show. It's just
it's so cool and weird.
It doesn't surprise me that this was found on an island, though, because islands are deeply strange places. And basically, I feel like islands are like evolutionary experiment stations where weird things happen. So I guess it isn't a surprise that we would find such a unique adaptation there.
Well, just think about it. Like, they're an island. They can get more and more and more specialized as time goes on. Like, fit whatever.
And sometimes there's not as many predators around, and there's a lot of factors that sort of constrict what can and can't happen. Yeah, islands are fascinating. We'll do a deep dive just on islands some week. Yeah. I will say that my sources for this week were an article on Gizmodo, the Smithsonian Magazine, and the actual journal article that talked about the species was called Hawaiian Caterpillar Patrols Spider Webs, Camouflage, and Insect Prey's Body Parts. That can be found very recently in the April 2025 edition of the journal Science.
Thanks, Kirk.
Very cool. All right, we're going to take a quick break, and we'll see what Rachel's got for us. Hey, before we get back to the show, we've gotten some comments online. We don't always remember to read them all. A couple just popped up here, though. Do you remember our episode, Whistle Pig Wagyu?
Yes.
That was the title of our 4th year anniversary show. And we got a couple comments on that. Big Grease just gave us a smiley face with some sunglasses.
It is pretty cool.
Appreciate the effort.
Thanks.
And then listener Christy McClellan, hey Christy, said, I love your anniversary shows, and it was great to hear a consensus on eat, ride, or jacket.
Yeah.
And she had an emoji face as well. So that was super fun. We got to wait an entire year to play Eat, Ride, or Jacket again. That's so much fun.
Can hardly wait.
And then looks like Arnow, I believe, said for the episode, which episode was this? The most venomous spider in the world, said, incredible, great show. Thanks for sharing it. So you are welcome. We love to hear from you guys. Thanks for reaching out.
Thanks for your comments, everybody.
And we'll get back to the show.
Okay, welcome back, everyone. I have some of the most exciting news. I'm really glad, Kirk, that you brought some recent scientific research.
Yeah.
What you shared was very exciting. What I am sharing, I think is absolutely amazing, and I love it very much. And I think it's the most exciting news, and I can't wait to share it with everyone. This study was...
okay.
I'm so excited. Okay, so this study was published March 26th, 2025. So super recent. As of...
Okay, wow. Brand new. Yeah.
No joke. Honestly, no joke. I was sent this by no less than 3 different people over multiple platforms.
Okay.
Yes. Well, our audience knows us well and what we want to hear about.
They all knew.
Thank you, listeners.
And for me to be this excited, and for my friends and listeners to know that I would find this fascinating, and to have seen it and shared it with me within the week of it dropping, it's got to be about sharks.
Oh.
Okay.
This is brand new information, and more studies need to be conducted, but that's enough setup. Scientists found out that sharks can make sounds. I'm too excited.
Oh, yeah. I think I saw a headline about this.
Yeah.
Sharks found out that scientists can make sounds.
Woohoo! This just in. Scientists found out sharks can make sounds, which is so cool. So the historical precedent has been...
What do they sound like?
Exactly. So the historical precedent has been... As cool as that would
That'd be amazing if that's what a shark sounds like.
That would be phenomenal. It's not quite that, but you're not hugely far off. So,
okay.
I'll get into it. So,
Please do.
the general idea that people have had for a very, very long time is that sharks don't make any noise. We haven't really recorded any noise coming from sharks. We haven't seen them make any noise. They don't have swim bladders, so that's really hard to be able to do that. So
they are silent but deadly.
Unusual. Exactly. Okay. But it's not unusual for a fish to make no noise, but the ability to communicate with sound has been documented really heavily in other marine organisms, such as whales, dolphins, thousands of fish. And obviously, this has been challenged with this study. It was published in the Royal Society of Open Science, and yes, it is open access. We love it.
Woohoo!
And
yay!
What happened was one of a PhD student was working on her research and heard rays making clicking sounds when divers were approaching.
Okay.
Like high-pitched, clicking noises.
Okay, and rays and sharks are very closely related.
They are very closely related. So Carolyn Nieder, who is the lead author of this story while working on that PhD in New Zealand at the University of Auckland, she was one of the folks who noticed this.
Go New Zealand.
Yeah. And they were testing, while she was working on her PhD, the research they were conducting was the hearing capabilities of sharks and like several different shark species. And they noticed that when the sharks were picked up and were handled, they would crackle. And they were like, that's a weird noise.
Crackly sharks, huh?
Crackly. And they were like, are they making that noise? Or are they purposely making this noise? Or is something else happening? So obviously Caroline had to know. Carolyn, so sorry. Had to know what was going on. These were rig sharks.
Yeah.
That she was handling. They go by a couple different names, but generally the group is rig sharks. So they had to figure out if it was purposeful and if the sharks were the ones making the noise. So Nieder and her team placed one by one 10 sharks in a tank, outfitted with sound equipment, and they picked up the shark
beams,
for a number of for 20 seconds, okay? And they were recording what they were doing, and they noticed that when they were handled, that's mostly when the clicks happened. And then they listened.
Okay.
Every single one of the sharks tested made this high frequency click, and it seemed to be in some sort of response to being startled. So they got more clicks right when a handler picked them up or started handling them versus on the latter half of the 20 seconds of being handled. So it seemed to be more in response of being startled. But how do they make the sound, right? Most fish can make sounds, but they make that sound by vibrating their swim bladder, which sharks famously do not have.
Don't have. Yeah.
No. So they looked at the shark, and rig sharks are really interesting because they eat crabs. So they have a set of flattened teeth that overlap within their jaw and their mouth. So they were thinking that if the jaws snapped together, it would produce those clicks. Like the teeth would be the ones that are making those clicks because they clack together. They made a reconstruction of the shark's jaw to test that out and see. That seems to be what happened. And it's just so cool. Like, sharks make noise. So obviously there's so many other questions. This is so new. more research needs to be conducted. So if you want to know why or how sharks make noise, please do so and tell me about it. Like, there's so many things to study and like have questions about, like, do sharks only make this in response to predators? Is it what stimulus causes sharks to make this noise? Do all sharks make this noise?
Right.
Is it just when they're handling? Is this something that they use to communicate with other sharks? Because it seems to be outside of their hearing range. In general, the noise frequency is outside of their range. So it's like, why are they making this noise? Are they trying to, they have observed cod making similar noises to deter seals? So is it something to do with that? Do they make other noises that we haven't been able to detect? How do they make those noises? So many questions. There's so many questions. And it just like opened up this whole avenue that we didn't even think about, just because someone noticed something and was like, what's that about?
So sharks are no longer the silent killers of the sea.
They are not.
They're the clicky
They're the clicky
killers
noise
of the sea. That sounds just as bad.
Yeah. I will say I did listen to the noise. It is very much a high-pitched kind of noise. Like, just like a tongue click.
So not...
Unfortunately, no.
Okay.
No, but it is like a one-note thing.
That would have been... Let's go.
Exactly.
But it's really high frequency, though.
Yeah, it's a really high pitch.
It's a stretch. Okay.
I tried. So my sources this week.
That's wild.
Now it's fascinating.
Yeah, I guess it doesn't surprise me that they can make some kind of noise. Like, it was more unusual that they couldn't, right?
Kind of, yeah. We just haven't, with all of the audio equipment we've done, and like we've listened for whales and all of these noises in the ocean, it makes sense that they can make noise and are able to communicate maybe that way, but we've never observed it. And we haven't figured out exactly how they could make noise, right? Because most fish use a swim bladder of some sort. They don't have vocal cords or anything like that. So it's
I'm curious if other sharks do this as well. Like, someone's got to go pick up startle some great whites and see what they do.
No, thank you. I do not volunteer.
The best idea.
What's your job? Well, I professionally startle great white sharks.
Woo! You get
it's a weird job, but someone's got to do it. Maybe. Paid upon completion of work. Cool.
Yeah, it was so cool. Very fascinating. My sources this week was an article in the Scientific American and the journal article itself, Evidence of Active Sound Production by a Shark by Carolyn Nieder, Eric Parmentier, Andrew Jeffs, and Craig Radford. Wow, I'm struggling. Anyway, thank you all.
Words are hard today. That's
Words are hard today. I made it through. You all are amazing. I hope that you learn more amazing things about shark noises, because I want to know. And I think that's it. I think that's the end of our show, everyone.
Sure is. All right.
Thanks for listening, everyone.
Have a good night.
Bye.
See you next time. Bye.
Thanks, everyone, for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all our listeners. If you would be so kind as to leave us a 5-star rating and review wherever you get your podcasts, that would be great. It lets other lovers of the strange discover the show. You can reach us by searching for Strange by Nature Podcast on Instagram, Facebook, and Blue Sky. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can check out our website, strangebynaturepodcast.com, and you can support the show and get ad-free episodes at patreon.com/strangebynature. Until next week, get outside, stay curious, and embrace the strange.